This question tests your understanding of orbital hybridization. Read all 5 statements carefully and ensure you understand all the terms used. Our plan for this question should be simply to test the validity of each statement using what we know about orbital hybridization. Let's start solving the question and see how it goes. Answer A states that water molecules are bent because the central oxygen atom is sp2 hybridized. Well, let's see what we know about the shape and hybridization of a water molecule. Start by drawing the Lewis structure. Water has 8 valence electrons, 1 from each hydrogen and 6 from oxygen. So the Lewis structure will look like this. There are 4 electron domains, which means the oxygen atom must have 4 hybridized orbitals. To get 4 orbitals, we need 1 s orbital and 3 p orbitals. That means the hybridization is sp3, not sp2. So before we even check the shape of the water molecule, we know that this one is false. Let's move on to answer B. This one says that 6 atomic orbitals must be combined to get a set of sp3d2 orbitals. Well, to get sp3d2 hybridization, we need 1 s orbital, 3 p orbitals, and 2 d orbitals. That's a total of 6, so it looks like this answer is correct. Let's check the other answers, just to be sure. Answer C states that for an sp3d hybridized orbital with less than 5 bonding electron domains, the non-bonding electron pairs are in the axial positions. First of all, we need to know what the geometry is around an sp3d hybridized atom. To make an sp3d hybridized atom, we need 1 s orbital, 3 p orbitals, and 1 d orbital. That's a total of 5 atomic orbitals. So the geometry we're looking for must have 5 electron domains. That's a trigonal bipyramid. Now if we had to place some non-bonding electron pairs around the center, would we place them in the axial positions like the answer suggests? Remember, a lone pair takes up more room than a bonded pair of electrons, so the lone pairs will go wherever there's more room. In a trigonal bipyramid, the angle between the axial sites is 90 degrees, whereas the angle between the equatorial sites is 120 degrees. So the lone pairs would have to be in the equatorial positions, not the axial ones. This answer is false. Answer D says that all carbon atoms in hydrocarbons are sp3 hybridized. Well, this is true for saturated hydrocarbons, where each carbon atom forms 4 bonding electron domains. It's not true if the hydrocarbon is unsaturated. In other words, if it contains double or triple bonds, since this would reduce the number of electron domains. Finally, answer E states that the carbon atoms in benzene are all sp hybridized. Recall the structure of benzene. You can see that each carbon atom has 1, 2, 3 separate electron domains. So the carbon atoms must be sp2 hybridized, not sp. This one's false too. So the answer is definitely B.